Okay, so in this video, we're going to actually compute one of these integrals, and I'm going to focus on this first integral. And so at the end, I'll explain why they're kind of both going to use the same trick. So let's just do the first one, and then I'll leave the second one for exercise. So with the first one, my first step was to square things out and open out these parentheses. So then you get something that looks like this. This is a typo. This should be x squared. So once I opened out those parentheses and squared things out, you'll see that some of these terms cancel. You have the plus 1 minus 1, plus 1 minus x squared, and then minus of that. And then these two terms add up. So you get 4 times that square root, and I just moved the 4 out in front of the integral. And how do we compute square roots like this? Well, this is ideally done with a trig sub. And so the typical trig sub to use is x equals sine of u, and then dx becomes cosine of u, cosine u du. And note that that means that u is inverse sine of x, and so when I change my bounds, the -1 becomes -π/2, and the +1 becomes +π/2. And when I replace the things in the integral, I get cosine u times cosine u du. So I did a couple steps there. So I used the fact that 1 minus sine square u is cosine u. And of course I plugged this in. So that's what we're integrating. And when you have a cosine square, you always use this the double angle formula to reduce that from a cosine square to just a cosine. Okay, so this is the trick for how we would integrate something that's just cosine square. We reduce that from a cosine square to just a cosine. We no longer have u, we have 2u, but it's still something that we can integrate using, just the antiderivative of cosine. So that's what I did in the next step. I integrated that because I know the antiderivative of cosine. Of course, that's a 2u, and so that's why I get an additional 2 in the denominator. You can think of that as in 2 steps, as doing a substitution, as making you can call v 2u, and then dv is 2 du. So you can split that up into 2 steps, and then you'll see that this is what you get as your antiderivative. And of course, the 1/2 just becomes a half u. And then when you plug in your endpoints, well, sine 2u just becomes 0 if you plugged in π/2 or minus π/2. So that term just disappears, and then you're left with just π/2, and so the answer is 2 pi square.